Okay, this is Andrew. In our last exercise, we took the network address 192.168.1.0 that was a /24, and we divided that into 6 subnets. And we went through the whole process and tabulated it all in this table, and this is what we got. So now, like I said, and what you're going to do is, in real life, you're going to probably, like if you have a job, you're going to use a subnet calculator like this. But you need to know how to do this specifically for if you take CCNA exams or various other exams, Network Plus, to get certified. You're gonna have to do this, on the exam, and they weave these problems in and out of other problems. So you really need to know this stuff very well. And also, you may be asked to do this stuff at interviews for a network engineering position. Okay, so it's important to know how to do it, but it's also important to know what tools are available to you to A, make sure you did it right so we can check our answers here, and B, to save time. Because at a job, you don't have hours to do this. They're going to ask you to do it quickly. So we enter our major network here, which is 192.168.1.0/24, because this is 8, 8, and 8 network bits, which is 24. And then we're going to enter the space that we need for our first network, which is 120. This is actually just how many IP addresses we need. We need 60. Now, if I wanted to, just as an example, if I wanted to add 10% to this 120, I could just do 120 plus 12 is 132 and put that in there, just to let you know. So 25, but this right now is what the problem is, and then we have the 3 links between the routers. Okay, so let's check that real quick. We have 120, 60, 25, 2, 2, and 2, and then we have 192.168.1. Okay, so that looks all right. So let's go ahead and submit this, and then we'll compare the results to our table here. Okay, so you can see this is the table that it generated for us. Let's compare this with the table we have. So let's look at the network addresses, subnet network addresses first. So that's 192.168.1.0, and the second one is a 128, a 192, 224, 228, and 232. So we go over here and look at our network address: 0, 128, 192, 224, 228, 232. Good. So that all looks right. Let's look at our broadcast addresses: 127, 191, 223, 227, 231, 235, 191, 223, 227, 231, 235. So our network and broadcast address look correct. Let's look at the assignable range as 1 to 126, 1 to 126, 1 to 190. 129 to 190, 129 to 190, 193 to 222, 193 to 222, 225 to 226, 225 to 226, 229, 230, 229, 230, 233, 234. Okay, great. So you can see, like, for this, the 225 and 226, we assign 225. This is often the way you see it written, 192.168.1.224/30. This is the subnet with its CIDR notation. And then the dot. So this, actually, on the interface of this router, you would go inside the router and program that the IP address on that interface to be 192.168.1.225. And then you have to convert the CIDR notation to the subnet mask, and I'll leave that to you, but it's going to be 225.225.225.whatever 30 is in the subnet mask. But we've been through that a number of times, so you should be able to do it. Okay, so in that manner, you assign all these IP addresses to the interfaces on the routers, and then On the clients, you're actually going to have a DHCP server, which can exist on a router, or it's going to be a separate server that we discussed. And that server is going to dynamically allocate these IP addresses from this range to the actual clients on the network. Okay, so I hope that helped you out a lot. I hope you have a good understanding of subnet, and particularly with variable length masking. All right, thank you.